Hello and welcome back to another episode of Math with Stone. Today we are going to be learning and reviewing how to graph for Algebra 2 or Algebra 2 Honors. So it's the first lesson in our entire year, so let's get into it. So there are three different forms of a graph. You can be graphing using slope-intercept form, which most people actually just call y equals mx plus b, where your m is your slope and your b is your y-intercept. But there are some issues with this format because at some point, maybe the y-intercept is a decimal and then it kind of makes it very difficult to graph. So there are limitations with all the forms, and that's just one of them. All right, so we're going to start off really easy. Your m is your slope. If it's a whole number, like it is here, that means it is 3 over 1, and the slope is how much you go up and then over by. And then your y-intercept here is -4. So we go and start with the y-intercept down at -4. 1, 2, 3, 4. Hopefully I counted correctly. 1, 2, 3, 4. And then if our slope is 3 over 1, we have to go up by 3 and over by 1. And we would get a straight line. And if you want to be even more accurate, A, you use a ruler, which I'm going to probably go and grab, and B, you can go up by 3 and over by 1 again to make your line even more accurate, okay? So the next one, you got a slope that is -2 over 3, which means instead of going up and then over, you go down and then over. Got my ruler now. We're going to start with our y-intercept at +2, up by 2. And then from here, I have to have my slope at -2 over 3, which is our slope. We go down by 2, over by 1, 2, 3. Down by 2, over by 1, 2, 3. You could backtrack it if you wanted to, but you don't have to. If you have a ruler, I would recommend using it. It makes it so much prettier. See, look at how much better that one looks. All right. Now, number 3 looks like an easier problem, and it is, but sometimes people don't understand what to do when it's just a singular x, so that's why I included this one. That means your slope is 1 over 1, and your y-intercept here is 2 again. So instead of going down by 2 and over by 3, I'm going to go up by 1 and over by 1, up by 1, over by 1, and then maybe backtrack it down 1, left by 1, down 1, left by 1, the other direction, to kind of continue that pattern before I draw my line. Woo! There we go. So here are the limitations with y equals mx plus b. If you have a y-intercept that is a decimal, you're in trouble. You can have a slope that's a decimal or a fraction because that's just up and over, but if you have this y-intercept that is 1.5, that's going to be kind of difficult to actually get some points at because you can go up by 1.5, and then you're like, well, now I have to go up by 2 and over by 1 because my slope is 2 over 1. So options for doing this problem could be plugging in values in a table. You could plug in some values for x and y in a table. No matter what form you have, if you need to be more precise, you should plug in more values that are precise. So if you plugged in, I don't know, let's say 1 for x, what would we get for y? Well, that one actually would be 2 times 1 plus 1.5, which would be 2 plus 1.5, which is 3.5, which is also not incredibly helpful, but that doesn't mean you can't plot it. X is 1, and the y value is 3.5, so 1, 2, 3.5, which is no different than going up by 2 and over by 1. So maybe we can find a clear value for y, but maybe that would be a trade-off and have to have a x value that's a decimal. So let's say that we wanted, I want to get the y value to be 5. Okay, so if I wanted the y value to be 5, that means that I'd be plugging in 5 for this y right here, and 5 would equal 2x plus 1.5. I would subtract the 1.5 over, you'd get 3.5 is equal to 2x, which means x is equal to 1.75, which is also bad. Okay, so we got 1.75 for x and 5 for y. So even though we were able to get a good y value, 1, 2, 3, 4, 5, but I got an ugly x value. But it is what it is. This line, when you draw it, might never have a clear, easy good looking point on it. And that's okay, but if you do have a situation like that, especially if the decimals are uglier and uglier, it's better to just draw and plot some of the points maybe than to just focus primarily on the slope. You can do the slope, but it's going to be a little less accurate than getting some accurate points that you get from plugging in some values. Okay, so that's y equals mx plus b. It's everybody's favorite. The next form that you have is standard form. Now, standard form, it's okay. A lot of times people, especially in math lower than algebra 2, they just take standard form and they immediately solve and put it into y equals mx plus b. They just get y by itself. But there are some benefits to standard form, and that is that you can get your x and y intercept, which tend to have some real-world applications, pretty quickly. So if we have 3x plus 2y equals 6, if you want to find your x-intercept, y will equal 0. If you want to find your y-intercept, x would equal 0. So we just plug in 0 for x to find the y-intercept. So if I plugged in 0, 3 times 0 plus 2y would equal 6. Well, 3 times 0 is nothing. So you really just have 2y is equal to 6, which means your y-intercept is 3. Okay, y-intercept 3. Let's plot it. 1, 2, 3, dot. What about the x-intercept? Well, the x-intercept, you plug in 0 for y, which means we'd have 3x plus 2 times 0 would equal 6. Well, that means that 3x is equal to 6, because that 2 times 0 goes away. That means if 3x is equal to 6, the x-intercept is 2. Okay, that was actually not too bad. We got 2 points. Anytime you have 2 points, you can draw the line. And if we do that here, we got our line. Okay, here we go. 2x minus y is equal to 4. Now, if you haven't noticed it yet, one time we had the x terms cancel out and it was just 2y is equal to 6. And then the other time it was 3x is equal to 6. So you can use what they call, what I call the cover-up method. If you want to find the y-intercept, you just cover up the x value, and you know that negative y would equal 4, which means the y-intercept is negative 4. And if you wanted to find the x-intercept, you would just cover up the y, and that would mean that 2x is equal to 4, and that means that the x-intercept is 2. And that's no different than plugging in 0, because if you plug in 0, it cancels out. So we got the y-intercept, we got the x-intercept. Let's plot them both. Negative 4, 1, 2, 3, 4. Positive 2. Graph your line. Use a straight edge if you got it. There we go. Now, we got another one. We got 2y is equal to 6, so that means if we cover up the x, we got y is equal to 3. And if we cover up the y's, we got negative x is equal to 6, which means x is equal to negative 6. So those are the x and y intercepts. We can plot them at positive 3 and at negative 6. 1, 2, 3, 4, 5, 6. And then we can get our graph. Now there is another trick that I'm hoping you start to recognize is in order to find the slope of any of these, all you have to do is take your y-intercept and put it over the x-intercept. Right? Let's think. Is it change in y over x? So let's see. If we did negative 4 over 2, that's close to that. Like negative 4 over 2, that's close. So we did go kind of like 4 and 2, but we didn't go up. It was positive. So maybe it's a negative version of that. Let's test it out. So this, if we did that, that would make this positive 4 over 2 as our slope. What about over here? Here, our y is 3, and our x is negative 6. So if we did 3 over negative 6, did we go up by 3 and over by 6? Yeah, but see how here it's saying it's a negative, and it should be a positive, so it's a negative version of that. What about here? Both of them are positive. We have a y of 3, which it was 3, and we went down by 3 and over by 2, and the x value was 2. So if we did 3 over 2 and made it negative, it would also give us our slope. So that tells us something that we're going to want to memorize maybe, that our slope is our negative y-intercept over our x-intercept. That would be our slope. Okay, that's kind of neat. Neat little trick that you could use. Last one for standard form. We got 4x minus 2y is equal to 5. Well, you may notice that 5 does not divide by 4, and 5 does not divide by -2. Both of those are ugh. But they are still points, and you could use them. And if we plot them, 5 divided by 4 for our x-intercept is 1.25, so a hair more than 1. And 5 divided by 2 is 2.5, so we're going to go, it's negative, so it's going to be -2.5. And this would be a scenario where you should also probably plug in a few more points, create a table. You also have the option of solving for y here and getting it in y equals mx plus b, get your slope and use that to get a few points. But it is really kind of up to your teacher as to how detailed do you want to be for that. All right, for me, sometimes all I care about is this and do a what's the slope type of deal. Depends on how you're feeling, depends on who your teacher is, and that would be determining how hard and how difficult you would actually need to be for that graph. My last form of an equation of a line is point slope form. Y minus y1 is equal to mx minus x1. Now these are my favorite because these are designed to be able to graph as is. You do not need to distribute and get your y equals mx plus b. You can, you definitely can. However, in this case, your point that is on the graph is going to be change the sign here and change the sign here. If we change both of these values, we will get our point. So we have a -4, that is going to be a +4. We have a -3, that is going to be a +3. That is our point in the point slope form. They call it that for a reason. So you change the sign of both of them. Right by 4, 1, 2, 3, 4. Up by 3, 1, 2, 3. And then the slope is the 2. So from here, we go up by 2 and over by 1. We get our line, and we graph it with a straight edge. All right? So you change the sign of both, and we would change the sign of the -2, get us +2. Change the sign of the +1, get us -1. There's our point, 2, -1. Right by 2, down by 1. And then our slope is right here. If our slope is 2/3, we go up by 2, over by 3. Get our point, graph our line. All right. Here we have a -3, change the sign, +2, change the sign. So -3, +2, what is our slope? Well, the number in front is our slope. If there is no number there, it's either 1 or -1. If it's a negative, then it would make it -1 or -1 over 1. So we have to go down 1 over 1 from the point, down 1 over 1 from the point, down 1 over 1 from the point, down 1 over 1 from the point. Make sure that you're doing your slope from the point that you draw, not from the origin, so to speak. Okay, last one. Here we have 1/3 x minus 0.5. If we have that, you can get your point, 0.5, change the sign, 4, change the sign, which is not a pretty point. 0.5 is here, and 4 is way up there. 1, 2, 3, 4. You can use a table of values for this. You can also, if you think that distributing will help, and getting it in y equals mx plus b form will help, then you can attempt that, which we might attempt. I don't know. Let's see, what is 1/3? 1/3 times 0.5 ends up being 1/6. I don't know if that's the play. If we distribute this, we get y minus 4 equals 1/3 x minus a 6. And then you got to add 4 to that. It just doesn't seem like it's going to be a beneficial thing. But we do know that the slope is 1/3. So if we did go up by 1 and over by 3, 1, 2, 3, what point would that be? You can create a table of values by plugging in things, but you can also create a table of values by really being careful with your counting and your slope. So we were at 0.5 comma 4. If I went up by 1 from that, I was going to be at 5 for my y value. If I go over by 3, I'd be at 3.5. So you can still get your net values, but I'm going to redraw that point. But it might be a little more careful of a process. 3.5 comma 5. There we go. So, graphing those two things, wrapping up the lesson, and then I'll be seeing you guys on the next one. I do want to go over some key features of things to remember. So, notes and summary. There are three forms of a line. You got y equals mx plus b. You got y minus y1 equals mx minus x1. That is the point slope formula. And then you have your standard form, which uses a's and b's, ax plus b, y is equal to c. Where here, you can get your x and y intercepts. Here, you can get a point on a line, which can be important, and your slope from the graph. And here, you get your slope, and you get your y-intercept. All three of these have limitations. If you have decimals, you are either going to need to be very careful or pay attention to a table that you graph to get more accurate. Sometimes, especially when you get up to statistics, you're going to have to get a line of best fit. What is most likely the line based off of the accuracy that you're given. But that's going to do it for this one. Until next time, everybody, stay positive, my friends, and I will see y'all later. Bye.